Good morning, students. So today's topic of discussion is alcohols, phenols, and ethers. Okay. So alcohol, phenols, and ethers. So these are some of the basic compounds. Okay. So where they are used. Okay. So alcohol, phenols, ethers, they are used in the formation of detergents, then antiseptic. Okay, antiseptic and this antiseptics, fragrances, etc. Okay, so they have a very wide range in your day-to-day applications. Okay, so what are these alcohols and phenols, how they are found? Okay, so when a hydrogen atom in a hydrocarbon, aliphatic and aromatic respectively, is replaced by OH group. So alcohols, it is in a aliphatic chain. So in a aliphatic chain, if one of your hydrogen atom is been replaced by OH group, then it results into alcohols. Okay, and in phenols, so in phenols, when phenols are found, that when a aromatic, okay, so when you have a aromatic hydrocarbon, so from a aromatic hydrocarbon, if one of your hydrogen is been replaced by OH group, then it is said to be phenols. Okay, so phenols are found. So an alcohol contains one or more hydroxy groups directly attached to carbon atom of an aliphatic system, while a phenol contains OH group directly attached to carbon atom of an aromatic system. Okay, so here in alcohol, it will be a aliphatic chain. So as I discussed that the OH group will be attached to a aliphatic system, while in the phenol, what happens? The OH group will be attached to a aromatic system. So the substitution of a hydrogen atom in a hydrocarbon by alkoxy or araloxy group, okay, yields another class of compound known as ethers. Okay, so another class of compounds which we are going to discuss is the ethers. So ethers are what? When you are substituting one of the hydrogen atom, okay, so hydrogen atom of the hydrocarbon, you are substituting by alkoxy group. What is alkoxy group? RO. Okay, R-O is a alkoxy group, and ariloxy is AR group. That is, if it is a aromatic, if it aromatic ring attached to O. Okay, so it yields another class of compound known as ether. So we yield ether. So example is your dimethyl ether, alcohols and phenols. So how they are classified? So they are classified into mono, di, tri, and polyhydric compounds, depending on the on whether they contain one, two, or three, or many groups of respectively. Okay, hydroxy groups. So depending upon how many number of hydroxy groups are present, they are classified into mono, di, tri, and poly. Mono means if one hydroxy group is there. Di means if there are two hydroxy groups. Tri means when they have three hydroxy group. Poly means if they are many. Okay, if they have more than three, then it is said to be polyhydric compounds. So these are some of the examples. You can see the first one, it is monohydric. So first is alcohol. Okay, aliphatic chains, it is alcohol. So these are all examples for alcohols. Above these one are alcohols. Okay, examples of alcohol. So this is monohydric, dihydric, and trihydric. So this is what? This is with respect to phenols. Okay, so this is example for monohydric. This is dihydric and trihydric. Okay, so this is based upon the number of hydroxy group present. So monohydric alcohols are further classified based upon the hybridization of the carbon. Okay, so if the see here, you can see the example. So if the OH group is attached to only one carbon, okay, if the OH group is attached to one carbon, then it is primary. So it is primary. So here the OH group is attached to the carbon which is further linked to another two carbons. So then it is said to be secondary. Okay. And what is tertiary carbon? When OH group is attached to a carbon which is further attached to three other carbon atoms. Okay, so then it is called as tertiary. So these are three, so primary, secondary, and tertiary alcohols based upon the this. Okay, where the hydroxy group is attached to the carbon. Okay, hybridization of carbon based upon the hybridization of carbon. So next is allylic alcohols. So in this alcohols, where does the OH is attached? OH group is attached to a sp3 hybridized carbon. You can see OH group is attached to a sp3 hybridized carbon, which is attached to the next carbon, which is having double bond. Okay, so that is called as allylic. What do you mean by allylic? So here the hydroxy group is attached to a sp3 hybridized carbon, which is next to a carbon-carbon double bond. Then it is said to be a allylic carbon. So here also you can see. So this is a carbon. It is so this is a hydroxy group. It is attached to a sp3 hybridized carbon, which is next to a carbon-carbon double bond. So same with respect to this. So hydroxy group attached to a sp3 hybridized carbon, which is next to a carbon-carbon double bond. So these are primary, secondary, and tertiary alcohols. So this is example for allylic alcohols. So what are benzylic alcohols? So benzylic alcohols, okay, benzylic alcohols, the OH group is attached to a sp3 hybridized carbon atom next to a aromatic ring. You can see here, right? So this is hydroxy group is attached to a sp3 hybridized carbon atom, which is attached to a aromatic ring. So based on this, you can see further examples. Okay, so benzylic alcohols, OH group is attached to sp3 hybridized carbon atom to an aromatic ring. So compounds containing CsP2, okay, vinylic alcohols. What do you mean by vinylic alcohols? So here OH, okay, so here you can see the example. Here OH group is attached to a carbon-carbon double bond. So directly it is attached to a carbon-carbon double bond. Then it is said to be what? It is said to be vinylic carbon. Okay, it is said to be vinylic carbon. So this is an example for vinylic alcohol. So OH group is directly attached to a carbon, which is double bonded. Okay, so carbon-carbon double bond is present. So thus it is a vinylic alcohols. So next is ethers. So what do you mean by ethers? So ethers are classified into simple or symmetric. So in the center O, right? How do you represent the ether? So R. So how do you represent R, O, R dash, right? So this across the O. So if both the atoms, okay, R and R dash are similar, if the same alkyl group is present, then it is said to be simple or symmetrical. Okay, and if the alkyl, so across this oxygen atom, if both the atoms, okay, or both the atoms or groups are different, then it is said to be mixed or unsymmetrical ethers. So for example, for symmetrical ether is diethyl ether. So you can see here across this oxygen atom, okay, oxygen atom, ethyl groups are present. So it is said to be symmetrical. When it is said to be unsymmetrical, so across the oxygen atom, both the atoms are different. So one is ethyl group, one is methyl group. Okay, so it is ethyl, methyl, ether. Okay, so this is example for unsymmetrical ether. So next we'll start with the preparations of alcohols. Yes. So next we'll start with the preparations of alcohol. So first is from haloalkanes. Okay. First we are going to prepare our alcohols from haloalkanes. So here haloalkane taken is what? Ethyl bromide. Okay. Haloalkane means what? One of the hydrogen atom is been replaced by a halide group, right? Halogen atom. So here you can see it is a ethyl bromide. So ethyl group and a bromide group is there. So ethyl bromide, when it is reacted with KOH, KOH is a strong base, right? So KOH, aqueous KOH, what you get is ethyl alcohol. So your Br is replaced by what? Your Br is replaced by OH. So this is one example for your from this. Okay, how you can prepare your alcohol. So ethyl alcohol. So what is happening? OH. Okay, Br is replaced by OH. So it is ethyl alcohol. So another example, the Reagent taken is different. It is silver nitrate, okay, silver hydroxide. So what happens? Ethyl bromide, when it is reacted with silver hydroxide, okay, in the presence of silver oxide or water, you get ethyl alcohol and AgBr. Okay, only the difference is in side products. So here you can see. So this is the first preparations from alcohol from haloalkanes. You can prepare your alcohols. Okay, so this is the first preparation. Second is what? From alkenes. Alkenes, right? So here by acid catalyzed hydration of alkene. So you know Markovnikov's rule, right? So this will undergo a Markovnikov's rule. So addition of water across the double bond will across the double bond will be followed by according to Markovnikov's rule. So what is done? Ethene is taken. It is treated with water in the presence of H2SO4, hydration of alkene. Okay, acid catalyzed reaction means it is undergoing hydration in the presence of acid, which is the acid taken concentrated H2SO4. You are going to heat it. Okay. So what you do, take ethene, okay, react it with water in the presence of H2SO4, heat the mixture. What you get is ethyl alcohol. Okay. So across, so it will be CH2 double bond CH2, right? So when you add water, what it will be? CH. So one you add, okay, and at one end you add your, so it will be what? CH2, right? CH2, CH3, CH2OH. Okay, so this is the product. So this is the product. So ethene will give you ethanol. Propane will give you propane to all. Okay, so like this products you will get. So this is the second preparation of alcohol. So next is from hydroboration, oxidation. So why hydroboration? Hydroboration is nothing but you are going to add diborane. Okay, B2H6. B2H6 is what? Diborane. So diborane you are going to add across. So it is the good oxidizing agent. So diborane in the presence of water. Okay, so 1-butene, the starting reactant taken is 1-butene. So what happens here? CH2, 3 CH2. CH2, CH2OH. Okay, so you're going to add the water molecule. So it is what? You're going to add oxygen. So oxidation is what? Addition of oxygen. So it is an indirect addition of water by anti-Markovnikov's rule. So it follows the anti-Markovnikov's rule. Okay, it follows anti-Markovnikov's rule. So these are some of the next reactions. Okay, by reduction of carbonyl compounds. So by doing the reduction on carbonyl compounds, which are the carbonyl compounds? Okay, aldehyde ketones. These are nothing but your aldehyde. These are your carbonyl compounds. Okay, so first we'll see if you want to convert or you want to convert aldehyde to alcohol, primary alcohol. You are going to use the reagents like the reducing reagents like lithium aluminum hydride in the presence of ether. Okay, it is applicable. So by using these three agents, okay, you can see sodium borate, okay, in the presence of ethyl alcohol. Next reagent is H2, okay, hydrogen in the presence of platinum. So by using this three reagents, you can convert your aldehyde into primary alcohol. The second conversion is from ketone to alcohol, right? CHOH. So this is what? A secondary alcohol. So if you want to convert ketone into secondary alcohol, so these three reagents, by using these reagents, you can reduce. Okay, you can do the reduction of this particular ketone. Next is if you want to do a reduction on carboxylic acid. Okay, carboxylic acid, then to primary alcohol. So it can only get reduced. Okay, it can only get reduced with the help of lithium aluminum hydride or ether, in the presence of ether. So this is the first reagent. It is not applicable with second and the next one. Okay, then if you want to reduce your acyl chloride, okay, if you want to reduce your acyl chloride, so lithium aluminum to primary alcohol, okay, you can use the first reagent lithium aluminum hydride in the presence of ether, and the second sodium borate in the presence of ethyl alcohol. So it won't be reduced with the help of H2 in the platinum. Okay, so by this making use of this reagents, you can do the following conversions of this carbonyl compounds. So from Grignard reagents, okay, from Grignard reagent is very important reaction. So Grignard reagent, if you are using RMGX is your Grignard reagent. Okay, Grignard reagent, if you react it with formaldehyde, formaldehyde is what? H. Okay, HCHO. So formaldehyde, if you react your Grignard reagent with formaldehyde, it yields you primary alcohol. Remember this. So if you react your RMGX with aldehyde, aldehyde means R can be anything. Okay, R can be CH3, that is methyl group, ethyl group, propyl group, anything. So aldehyde group. So if R can be anything here it should be only formaldehyde. So if it is formaldehyde, that is, if it is only H, so then it will yield you primary alcohol. So here, if you take a aldehyde, okay, so it will yield you a secondary alcohol. It will yield you a secondary alcohol. Okay. So it will yield you secondary alcohol. Then if you take ketone, so with the help of ketone, what it will do? Ketone. So ketone, it will, when you react it with RMGH, you yield tertiary alcohol. So carbon is attached to other three alkyl groups. Then it is said to be a tertiary alcohol. So based on this, we'll solve some questions. So the product of acid catalyzed hydration of 2-phenyl propene is, yes. Yes, the product of acid catalyzed hydration of 2-phenyl propane is. How we will solve this? What is the correct answer? So first we'll write the reaction. Yes, correct. Okay, I'll write the reaction. So 2-phenyl. Okay, at second position you have your phenyl group. So this is 1, 2, and 3. So 2-phenyl propene, when it reacts with your, what it undergoes? Hydration. Okay, in the presence of this acid catalyzed reaction. Okay, so it will give, so it will follow what? Markovnikov's rule, right? It will follow Markovnikov's rule. We have seen this. So what it will be? What will be the product? So it will be COH, CH3, and CH3. Okay, so it is 2-phenyl propane 2-ol, like this. Okay, so like this you are going to solve. Okay, so it will undergo acid catalyzed hydration of 2-phenyl propene. So it undergoes Markovnikov's rule. Okay, so OH will be added to the carbon having least number of hydrogen atoms, and this hydrogen will be added to the carbon having a more number of hydrogen atoms across the double bond. So it will follow what? Markovnikov's rule. So this is the first one. So the answer is what? C. The answer is C. So next is carbon monoxide plus H2. Okay. So the condition is 300 degrees Celsius, 300 atmosphere. Okay. Atmospheric pressure, and halide is the catalyst taken. So which is the catalyst taken? They have asked which is the catalyst X here to convert your carbon monoxide plus H2 to CH3OH. They have asked which is the catalyst taken. Okay, the catalyst X is. So we have to find, we have to tell them which is the catalyst. So here the catalyst taken is B. Okay, chromium oxide in, or in the presence of zinc oxide. So here the reaction goes like this: CO plus H2. Okay, CO plus H2, 300 degrees Celsius or 300 atmospheric pressure in the presence of Cr2O3. So this is a what? It is a good oxidizing agent. Okay, chromic oxide or zinc oxide gives you what? It will give you CH3OH. Okay, it will give you CH3OH. So this is an industrial preparation of methyl alcohol. So you can prepare your methyl alcohol industrially. So in industry, if in large quantity, you can prepare your alcohol by this method, by using this particular catalyst. Okay, so this is the catalyst which is used. So to balance, it will be 3. So next, we'll see the next one. The product of the following reaction. Okay, so the reaction is given here. What is the reaction? 2CH3MgBr plus this formaldehyde, right? So when you react your formaldehyde with Grignard reagent RMgX, so this is RMgX, right? So this is a Grignard reagent. So what you will yield? It should yield a primary alcohol, right? It should yield what? It should yield a. So what is the answer? So I'll write the reaction. Okay, in the presence of water, so it will give CH3, CH2OH. So the answer is ethyl alcohol. So the answer is ethyl alcohol. Okay, so the answer is ethyl alcohol. The product which is formed. So when you react RMgX, so it with formaldehyde, it yields you ethyl alcohol. So next we'll see the chemical properties of alcohols. Okay, so what is the acidic nature? So it is having acidic nature. So why it is having acidic nature? Because it reacts with sodium metal. Okay, so alcohol, when it reacts with sodium metal, what it forms? Sodium alkoxide. You can see it forms what? It forms the sodium alkoxide. Okay, this is called as sodium alkoxide. So RONA. Okay, so this is sodium alkoxide plus H2. So these alcohols are Bronsted acids. Okay, what are Bronsted acid? They can easily give protons. Okay, so they can easily give protons. So these can easily release this proton. So alcohols are Bronsted acids. These are weaker acids than water. So alcohols are weaker acids than water. Presence of electron withdrawing group. So if you have electron withdrawing group on alcohols, what it will do, which are the electron withdrawing group? Nitro groups, cyano groups, okay, any halide group. So if it is present on the alcohols, it will increase the acidic nature. So what it will do, it will increase the acidic nature. Okay, so so this is the first property, that is alcohols are acidic in nature. And if there are presence of electron withdrawing group, what will happen to the it will increase the acidic nature. So more the alkyl group. So more the alkyl group, what will happen to the acidity? It will be less. So lesser is the acidity. So based upon the, so you can see here R groups. Okay, if one is there, it is more as compared to three. So primary is more stable than secondary and tertiary. So primary, if you have a primary alkyl, okay, group, okay, so then it will be primary alcohol will be more stable than secondary and then tertiary. So more alkyl groups means lesser the acidity. Next is esterification reaction. What do you mean by esterification reaction? When your acid is reacted with alcohol in the presence of acid. Okay, so when your acid is reacted with alcohol in the presence of strong acids like concentrated H2SO4, it will undergo acid catalyzed reaction to form a ester. Okay, what is ester? So this is a, so your one example is given. So acetic acid is taken, it is reacted with ethyl alcohol. Okay, it is reacted with what? It is reacted with ethyl alcohol. In the presence of what? Concentrated H2SO4, what you obtain is ethyl acetate. What you obtain is ethyl acetate. So the product, how it is obtained, just see here. Okay. So water. So the side product obtained is water and CH3CO C2H5. Okay, like this. So in this reaction, why this concentrated H2SO4 is used? It is a dehydrating agent. Okay, it is used to remove the water. Okay, it is used to remove the water molecule and it absorbs the water which is formed in this reaction. So what is the role of H2SO4? It is used as a dehydrating agent, right? So from your acetic acid and alcohol, the side product obtained is water. So this H2SO4, what it is acting as? It is acting as a dehydrating agent. Okay, so if you take alcohol, and you react it with the carboxylic acid, okay, if you react it with carboxylic acid in the presence of H plus ions, you yield what? You will yield a ester. Okay, you will yield a ester. So you will yield a ester. So if you react your alcohol with the acid anhydride, so acid anhydride, okay, acid anhydride like this. So acid anhydride, if you take acid anhydride, okay, with your alcohol, it yields you what? Ester. So these are the three methods from which you can form your esters. The next is with acid chloride. Okay, acid chloride. C double bond O, Cl. So if you take acid chloride and react it with alcohol, you will yield ester. So these are the three methods from which you can yield your ester. So one is with carboxylic acid, second is with acid anhydride, and third is with acid chloride. So in this esterification reaction, OH part of the carboxylic acid and H of the alcohol are removed as water, right? We had seen this. So from OH part of carboxylic acid, what is removed? OH part is removed from this and H part is removed from the alcohol, and the side product obtained is water. So these are the esterification reactions. So next is dehydration of alcohols. What do you mean by dehydration? Dehydration is nothing but removal of water molecule. So alcohol is taken, a primary alcohol is taken. It is reacted with what? Concentrated H2SO4. What is the role of H2SO4? It is a dehydrating agent. So the temperature provided is 433 Kelvin. What you yield is you yield a alkene. You yield a alkene. So there is a removal of water molecule. There is a removal of water molecule. Okay. So you yield a alkene. So this is dehydration of alcohols. So reactions of primary alcohol. So we'll see how, if what are the various reagents can be used with alcohols to prepare different products. Okay, so a primary alcohol, if it is treated with K2Cr2O7 potassium chromate. Okay, so if it treated with potassium chromate in the presence of H plus ions, what you get is carboxylic acid. So here the carboxylic acid which is there, it is will be having same number of carbon atoms. So when you react your alcohol, primary alcohol with your what? If it is reacted with K2Cr2O7. So the reagents, these are the various different reagents. So if the reagent is K2Cr2O7, potassium dichromate, in the presence of H plus ions, you yield what? Carboxylic acid. So the carboxylic acid formed will be having same number of carbon atoms. Second is with CrO3 or PCC. Okay, you yield what? It is undergoing oxidation. Okay, it is undergoing oxidation. It will form aldehyde. So it is converted into aldehyde. Alcohol is converted into aldehyde using PCC or CrO3. Then if it is treated with copper, metal like copper in the presence of 573 Kelvin, okay, it is aldehyde. It is obtained as aldehyde. So from your dehydrogenation, what do you mean by dehydrogenation? Removal of H2 molecule. Okay, it undergoes a dehydrogenation reaction. There is a removal of H2 molecule. It yields you aldehyde. Next is with anhydrous ZnCl2 and concentrated HCl. What do you mean by this? Which is this reagent? What is the name of this reagent? Anhydrous ZnCl2 and concentrated HCl. It is Lucas reagent, right? It is called as Lucas reagent. So when you react your primary alcohol with Lucas reagent, there is no reaction in cold conditions. So it does not show any reaction. Then if you treat your alcohols with concentrated H2SO4 and the temperature is 413 Kelvin, okay, so the product obtained is it is a ether. So it is a ether. So the product obtained is a ether. Okay, it is a ether. Alcohol plus this, okay, it yields you a ether. Then when alcohol is treated with thionyl chloride or PCl3 or hydrogen halide, it yields you what? It yields you a alkyl halide. So here also it is a alkyl halide. So we'll go to the next one. So next is reaction with secondary alcohol. So as we had discussed the primary alcohols, we'll see the reaction with secondary alcohol. So this is the secondary alcohol. Okay. So oxygen is attached to the carbon, which is further having two alkyl groups. So this is a secondary alcohol. So secondary alcohol, when it is treated with oxidizing agent like potassium dichromate, it yields you what? Carboxylic acid. But here in the first case, the number of carbon atoms remain same. But here there is less number of carbon atoms. Okay. Then if you treat it with chromate, so this is Cr2O3 or PCC, then you yield what? You yield a ketone. So this is ketone. Then if you treat it with copper in the presence of 573 Kelvin, you yield what? You yield a ketone. Okay. Then if you treat it with Lucas reagent, ZnCl2 and HCl, Lucas reagent, it will give you a turbidity. Okay. So this is a alkyl halide. So here you get a turbidity in 5 minutes. You get a reaction. So in the previous, when primary alcohols react with your Lucas reagent, there is no formation of PPT, okay, in cold condition. And your Lucas reagent, when it reacts with primary alcohol, it gives you a turbidity after 5 minutes. Okay, in 5 minutes, it gives you turbidity. So reaction of tertiary alcohol. Next, we'll see tertiary alcohol. So These are this is a tertiary alcohol. OH group is attached to a carbon which is next to three alkyl groups. Okay. So what happens here? So if you treat it with potassium dichromate, so mixture of ketones and carboxylic acid which are having less number of carbon atoms is yield. Okay. So you can see with various. So you have taken the reagents remain the same. Only the starting product is reactant is differing. So based upon the starting reactant, you can see different what primary, secondary, and tertiary. So based upon the type of alcohol you take, the product is differing here. So next is with the Cr2O3 or PCC. Okay, it gives you no reaction. It gives you no reaction. Then this what? Because there is no alpha carbon present. Okay, there is no alpha carbon present near carbon, so that it gives no reaction. Okay. Then when you treat your tertiary alcohol with copper in the presence of 573 Kelvin, it yields you what? It yields you a alkene. Then Lucas reagent. Okay, when you treat your tertiary alcohol with Lucas reagent, it gives you turbidity immediately. Okay, the turbidity which is given, or it forms the turbidity immediately. So based on this, we'll solve some questions. So the best reagent to convert pent 2 into all into pent 3 into on is. Okay. So the best reagent to convert pent 3 into all into pent 3 into on means from alcohol it is converted into what? Ketone. Okay, which is the best reagent? It is A. It is pyridinium chlorochromate, that is PCC. Okay, pyridinium chlorochromate. Okay, I'll write the reaction. So the reaction goes like this: CH3 CHOH CH double bond CH3 in the presence of what? PCC. So this is what? Pent, right? Pent 3 in 1, 2, 3, 4, 5. Pent 3 in 2 all. Okay. Pent 3 in 2 all, when it is treated with PCC, what it will do? It will yield you a ketone. Okay. So it will yield you a ketone. So there is a alpha hydrogen present here. It undergoes oxidation. Okay. There is a removal of hydrogen atom and it undergoes what? It undergoes oxidation. So with the help of pyridinium chlorochromate. So this is the best reagent which is used. Okay. So in the following sequence of reaction, okay, in the following sequence of reaction, so we have to here tell which is A, B, C, and D. So we have to solve it. Okay. So they have asked only D. So how you'll obtain D? By solving this A, B, and C. Okay. So which is the compound D they have asked. So our starting reactant is CH3, CH2OH. Okay. CH3, CH2OH. Then this is treated with what? This is treated with P plus I2 phosphorus, okay, plus iodine. Then what it gives you? OH is replaced by which nucleophile? Iodide. Okay, CH3, CH2I. So this is our A. This is further treated with what? Mg in the presence of ether. Okay, Mg in the presence of ether means, so it will be what will it will be? So it will be CH3, CH2, MgI. Okay. So this is your B. So this is your B. Now this is further treated with what? Formaldehyde. So this is further treated with formaldehyde. So what is happening here? CH3, CH2. Okay. There is, so from this what adds is your CH2. Okay. CH2. So across here, in between these carbons, your again there is a addition of carbons. Okay. So there is addition. So here there is increase in the carbon chain. So your CH2O gets added. So this is a CH2O added from the formaldehyde. Okay, and you get MgI. So this is your C. This is your C. This is further treated with what? It is further treated with your water. So what you get is CH3, CH2, CH2, OH plus Mg, OH and I. So what is the product? It is N-propyl alcohol, right? 3 carbons are there. It is in a straight chain. So it is N-propyl alcohol. So this is the answer. Okay. So the final product of the oxidation of ethyl alcohol is, yes, anybody? What is the answer? So we'll solve this. Sixth one. So what is the final product of the oxidation of ethyl alcohol? Okay. So the answer is ethyl alcohol. We are going to do what? We are going to do oxidation. So on oxidation of ethyl alcohol, what it will do? It will do a carboxylic acid. Okay. So the answer is what? Carboxylic acid. So it is what? It is a, which is this name? It is a acid. So it is acetic acid. So from alcohol, primary alcohol, when you do oxidation, it yields you carboxylic acid. So the name of this acid is what? It is acetic acid. Okay, it is acetic acid. So the correct answer is B. Correct answer is B. So next, the organic compound A. Okay, an organic compound A containing CH and O. Okay, CH and O is carbon, hydrogen, and at oxygen. So what they have asked, so there is an organic compound which is unknown. It is A, which is containing carbon, hydrogen, and oxygen. It has a pleasant odor with boiling point of 78 degrees Celsius. On boiling this A with concentrated H2SO4, a colorless gas is produced which decolorizes bromine water and alkaline KMNO4. So which is the, what is the organic liquid A? Okay. So the organic liquid A is, okay, it is ethanol. It is ethanol. Okay. So ethanol, it has a boiling point of 78 degrees Celsius. So I'll write the reactions. So ethyl alcohol, first they have, what they have done, they have treated it with concentrated H2SO4. Okay. And they have heated it. So what you will yield? You will yield the ethene. So ethene. So you will yield ethene. So with pleasant smell on boiling A with concentrated colorless gas is obtained. So this is a colorless gas. It is a ethene. Now this ethene, what is done with this ethene? So ethene is further treated with what? It is treated with bromine. Why it is treated with bromine water? Why? Bromine water, why it is used? Bromine water, it tells you the presence of double bond. It tells you about the saturation, unsaturation present. So across this double bond, what is added? Your Br is added. Okay. So again, and alkaline KMNO4. So this is the one reaction. Another reaction with your CH2. Okay, in the presence of KMNO4, this is also a good oxidizing agent. So what happens across the double bond? What is added? Across the double bond, your OH is added. Okay. So ethyl alcohol. So the organic compound A. Okay, the liquid A is nothing but it is a ethyl alcohol. So these are the reactions. One mole alcohol reacts with sodium to give what weight of hydrogen? Okay, so we have to see. So now we'll write the reaction. If I write this general equation, ethyl alcohol reacts with sodium, giving you 2. Okay, it gives you ethyl sodium alkoxide, right? It is a sodium alkoxide plus what is given. So this gets, so it is H2. Okay, H2 will be liberated. So this is 2 mole. This is 2 mole. This is 2 mole. Okay, and this is 1 mole. So what they've asked, 1 mole alcohol reacts with Na to give what weight of hydrogen? This is a general equation. Now they've asked for 1 mole of alcohol if you take, then it will be how much? For 2 it is 1. So for 1 it will be half. Half mole. Okay. 1 mole is equal to how many grams? There are 2 hydrogens. 2 hydrogens means it is 2 grams. Half mole means it is 1 gram. Right. So it is A. A is the correct answer. Understood? So I have written the general equation first. Then from that we have got it. So H2. So this is 1 mole. 1 mole, how many atoms are there of hydrogen? 2 atoms. 2 atoms. What is the mass? It is 2 grams. So for half mole, if it is for 2 mole, it is 1. For 1 mole, it will be half, right? So then the grams, that also you should divide. So it is 1 gram. So the answer is 1 gram. So if you'll see the physical properties, so lower members of highly soluble, the lower members are highly soluble in water because of hydrogen bonding. Okay, because of hydrogen bonding, solubility in water decreases with the increase in size of the alkyl group. So the lower members of alcohols are highly soluble. Okay, these are highly soluble in water. Why? Because of presence of hydrogen bonding, right? So see, alcohol, what it is? ROH, and your water is what? It is, right? So it is having a strong hydrogen bonding. So like this, okay, with alcohol, with your whatever. So the lower members are they are highly soluble, but the solubility in water decreases with increase in size of the alkyl group. So if based on this, so if the size of alkyl group increases, what will happen to the solubility of water? It will decrease. Okay. Then next is what? Boiling points of alcohols are higher than the expected because of presence of hydrogen bonding. So because of this presence of hydrogen bonding, the boiling points of alcohols are higher. Okay, because there is electronegativity factor, right? So there is a what? Partial negative and partial positive charge formation. So there is what? These are polar molecules, right? So because of this, what happens? The boiling points of alcohols are higher as compared, because as compared to other compounds, because of the presence of hydrogen bonding. So how do we distinguish between primary, secondary, and tertiary alcohols? So this is very important reaction. So it is called as the Groves reaction. In Groves reaction, which is the reagent taken, it is a Lucas reagent. What is the Lucas reagent made up of? It is anhydrous zinc chloride and concentrated HCl. So it is a mixture of anhydrous ZnCl2, zinc chloride, and concentrated HCl is nothing but your Lucas reagent. So primary alcohol. So how do we distinguish it? So if we take a primary alcohol and we react it with Lucas reagent, it gives no turbidity. Okay, there is no PPT formed. If secondary alcohol is present and you react it with Lucas reagent, turbidity appears within 5 minutes. So the turbidity appears within 5 minutes. So this is with secondary alcohol. Then tertiary alcohols, when it is reacted with Lucas reagent, the PPT obtained or the turbidity obtained will be immediately. So it will take no time. Within no time, there will be formation of PPT. Okay. So this way you can distinguish your alcohols, primary, secondary, and tertiary. So dichromate test is nothing but it is an oxidation test. Okay. If you react your primary alcohol, if you do oxidation on that, it is converted to aldehyde. If you further treat the aldehyde with oxidation, okay, then it will form acid, that is carboxylic acid. If secondary alcohols are there, okay, if secondary alcohols are there and if you do oxidation, it will convert it into ketone. Okay, ketone. See here, and tertiary alcohols, when tertiary alcohols are there, if you do further oxidation, there is no reaction. Why? Here you can see there is presence of alpha hydrogens. So hydrogens are there, alpha hydrogens are there. So you can easily remove the hydrogen, okay, and you can add your oxygen. But here there is no presence of alpha hydrogen. So because of this, it undergoes no reaction. So primary, it is first converted into aldehyde. Further treatment with oxidation, further oxidation, it gives you carboxylic acid. Secondary alcohol, if you do oxidation, it will give you ketone. Tertiary, they will not give you any reaction. So this is the oxidation test. So based on this, we'll solve some questions. From among the following alcohols, the one that would react fastest with concentrated HCl and anhydrous ZnCl2 is. Yes. So primary alcohols, they will form no PPT. Secondary alcohols, they will form PPT within 5 minutes. Then third tertiary alcohols, they will immediately give the PPT. So we have to see what? We have to see which one of the following, okay, which one of the following alcohol is a tertiary alcohol. So we have to see which is the tertiary alcohol among the following. So which is the tertiary alcohol among the following? Yes, which is the tertiary alcohol among the following? Which is the tertiary alcohol among the following? Yes. So the answer is what? B. Okay. B is the answer. It is 2-methyl propanol. Okay. It is 2-methyl propanol. What is the structure? It is a tertiary alcohol. So write the structures. Okay. Write the structure. You'll understand which is the tertiary alcohol. Okay. So it is B. It is the answer is B. B is the correct answer. Okay. Just a second. I'll share it again. Yes. Yes. I can write now. So what is the structure? So the structure of 2-methyl propanol. Okay, so 2-methyl propanol, CH3, 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 OH. Okay, 2-methyl propanol. Okay, 1, 2, and 3. So 2-methyl propanol. So this is the answer. Okay, so this is a tertiary alcohol. So tertiary alcohol with Lucas reagent will give you immediate PPT. Now next is what? An unknown alcohol is treated with the Lucas reagent to determine whether the alcohol is primary, secondary, or tertiary. Which alcohol reacts fastest and by what mechanism? So when you take, so you know, with Lucas reagent, which is the alcohol, which is it will form immediate PPT. It is the tertiary. Okay. So the correct answer is what? A. So tertiary alcohol, and it will undergo which mechanism? Okay, so this is the alcohol which reacts fastest and by what mechanism? So it is tertiary by SN1 mechanism. So what is the reason? So with Lucas reagent, tertiary alcohols reacts fastest by SN1 mechanism because of the formation of carbocation. Okay, because of the formation of carbocation which is formed in the rate determining step or the slow step. So the Lucas reagent, so the unknown alcohol is treated with Lucas reagent. So whether the alcohol is primary, secondary, or tertiary, and which of the alcohol reacts fastest and by what mechanism. So it is a tertiary alcohol, you know it, and it will undergo SN1 mechanism. What is the reason? Due to the formation of carbocation. Okay, it is due to the formation of carbocation. It is the reason. So next, the alcohol which easily reacts with concentrated HCl is. So, which is the alcohol which will easily react with concentrated HCl? It is B. Okay. C, CH3, 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 OH. So, it is a tertiary alcohol which reacts easily with halogen acid. Okay. So, this is the reason. So, it will easily react with the concentrated HCl. So, this is tertiary alcohol. So, you can see this is secondary. This is a primary alcohol. This is secondary alcohol. The first is A is secondary alcohol. Okay, this is a tertiary alcohol. Then this is primary alcohol. This is also a primary alcohol. So tertiary will react more easily, faster. Okay, with concentrated HCl. So the answer is B. Arrange the following compounds in increasing order of boiling point: propane 1-all, butane 1-all, butane 2-all, pentane 2-all. So, so based on the structures, okay, propane 1-all, So this is propane 1-ol. Okay. Then butane CH3, CH2, 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 OH. So this is okay. So this is a propane 1-ol. This is butane 1-ol. Then butane 2-ol, CH3, CH2, CH2, CH, OH, and CH3. So this is butane 2-ol. 1, 2, 3. Sorry, I've added an extra hydrogen. Okay, so it will be your CH3, CH2. So this is 4. Okay, 2. Butanol. Then pentane is what? CH3, CH2, 2, CH2, CH2, OH. Okay, so 1, 2, 3, 4, 5. So what did we discuss about increasing boiling point? That is with the alkyl group. So which will have more boiling point? So the answer is what? So you have to write with increasing. Okay, increasing order means what? First will your propanol will come. So first your propanol will come. Then second your what will come? Your butane will come. Okay, butane 2-ol. Butane 2-ol will come. Okay, so it will have, because it is a branch chain. Then what will come? Then will come your butane 1-ol. Then your it will come your pentane. So this is which is the correct. So it is A. A is the correct. So if linear alcohols are there, they are having more boiling point as compared to isomeric alcohol. So the correct answer is A. So you have to write the structure and write the trend. Okay, you have to write in the increasing order of boiling point. So preparation of alcohol. So we'll see preparations of alcohol. So from benzene sulfonic acid. So what is benzene sulfonic acid here? So benzene sulfonic acid is, so your sodium benzene sulfonate is taken. Okay, benzene sulfonate is taken. It is treated with sodium hydroxide. So what is happening here? There is a replacement reaction taking place. It forms a sodium phenoxide. So this is sodium phenoxide. Further treatment, it undergoes hydrolysis to give you phenol. So this is the first preparation. So always the phenol formation will undergo via sodium phenoxide. So intermediate form will be sodium phenoxide. So this is the first reaction from benzene sulfonic acid. So this is a sulfonic acid. So this is sulfonic acid. Next is from benzene diazonium chloride. So we had discussed about diazonium chloride in the previous chapter. So what is benzene diazonium chloride? How you obtain this N2Cl? That is when you treat it with NaNO2. Okay, sodium nitride with concentrated HCl. Okay, what is the temperature? 0 to 5 degrees Celsius. So this is a temperature maintained. You get benzene diazonium chloride, which on further hydrolysis, what it will do? So it will yield phenol plus N2 gas is released. Okay, this is N2 gas is escaped, and this is also gas HCl. So this is from benzene diazonium chloride. Next is Dove process. Okay, what do you mean by Dove's process? So your chlorobenzene is taken. Okay, aryl halide is taken. That is example is chlorobenzene. It is reacted with what? Sodium hydroxide. A temperature of 300 degree Kelvin Celsius and high pressure. Okay, this is the conditions. You get what? Sodium phenate. Okay, so sodium phenate is formed. So 2,0Na. What is your first product? So this is first reactant is Cl. Okay, from chlorobenzene. When it react with NaOH, so your chloro group is replaced by your ONe. Okay, ONa. So these are the reaction conditions are there. So this sodium phenate is unstable. It is an intermediate. So this on further treatment with dilute HCl, what will happen? What it will form? It will form phenol. Okay, so this is the another method of preparation of phenol. So this is the Dove's process. Okay, important reaction, Dove's process, benzene diazonium chloride. Remember this. Next is from cumene. So one of the important question, cumene. Cumene's process starts from isopropyl benzene. Okay, so this is isopropyl benzene. Okay, isopropyl. So propyl group is this. This is propyl group attached to a benzene. So this is isopropyl benzene, or it is called as cumene. Okay, cumene, when it is treated with O2. O2, what happens here? Oxygen is added in between this CH group. So oxygen is added between this bond. Okay, so what you get is it is a peroxy group. Okay, COO. COOH. So this is a peroxy linkage, right? So it is named as cumene hydroperoxide. It is cumene hydroperoxide, which on further hydrolysis yields you what? It yields you phenol and acetone as a side product. So you have to remember this, both the products. Acetone is also a major product here, so you need to remember both the products. So with cumene, if you treat it with oxygen, it forms what, which is intermediate, it is cumene hydroperoxide, which on further treatment with hydrolysis, when you do hydrolysis, it yields you phenol and acetone. Remember both the products, it is phenol and acetone. So from cumene you yield phenol and acetone. So next is chemical properties. Okay, so acidic nature of phenol. So why is the acidic nature? So whenever you want to check the acidic so it turns the blue litmus paper red. Okay, and it reacts with, so you can see the reaction. Phenol can react with both. Okay, it reacts with both. It reacts with metal also, sodium metal also, and alkalis also. This is alkali, right? Sodium hydroxide is an alkali to form their salt, which is the salt form sodium phenate. So this is sodium phenate. So it turns phenol, it turns blue litmus red, and it reacts with alkali and alkali metal to form salts. They are respective salts. So this is the first property, acidic nature of phenols. Next is, so when the proton is removed from the phenol, it forms phenoxide ion, which is more stable than phenol. So here, when you remove this proton, so when you remove this proton, okay, when you remove this proton, it forms what? It forms phenoxide ion. This phenoxide ion is more stable than phenol. Why? Because this phenoxide ion, it will undergo resonance. Okay, it will undergo resonance and it will show different this resonance structures. Okay, so this phenoxide ion, it is having a negative charge. So this negative charge is stabilized by the benzene ring. So phenoxide ion is more ion is resonance stabilized. Okay, it is resonance stabilized, so it is more stable than your phenol. So remember this. So whenever you remove the proton from phenol, the phenoxide ion which is obtained, it is more stable. Why it is more stable? Because this negative charge on the oxygen atom is stabilized by resonance. Okay, resonance of the benzene. Okay, on the benzene. So the negative charge is been what it is carried forward across this benzene. Okay, it is rotated across the benzene. So effect of substituent on the acidity of phenols. Okay, what is the effect? So you can see electron donating substituents. So whenever you have electron donating substituents like this alkyl groups, okay, if the alkyl groups are present, what will happen to the acidic strength? It will decrease. So whenever you have electron donating substituents, then the acidic strength of phenol will decrease. So this is less. So whenever, so this example is paracresol, the acidic strength is less than that of phenol because of the presence of electron donating substituent. Okay, so this is the first point. Whenever you have electron donating substituent, it will decrease the acidic strength. So this is the first point. Okay. Next is whenever you have electron withdrawing substituents. So whenever you have electron withdrawing substituent, what will happen? It will increase the acidic strength of the phenols. Okay, electron withdrawing substituents, it will, what it will do? It will increase the strength. So the strength of, so whenever you have groups like nitro groups, so it will be, the acidic strength of phenol will be more as compared to the phenol. So this is the second point. So what is carboxylic acid? Carbolic acid is nothing but, it is a phenol. Okay, carbolic acid is nothing but, it is called as phenol. Okay. So among the following, which is least stable? Yes, among the following, which is least stable? So we have to see, what did we say? Whenever you have electron donating groups, okay, whenever you have electron donating groups, what will happen? Electron donating groups, it will, the acidic strength will be less. Okay, so the answer is what? The answer is orthocresol. So cresol group, right? Cresol. Orthocresol. So electron donating withdrawing groups like nitro and chlorine, okay, they decrease the electron density in the ring and thus increase their acidic strength. So which is least stable is your orthocresol. So whenever you have nitro groups, then chloro groups, so these are it will increase the acidic strength. So whenever you have electron donating group like CH3 group, it will decrease the acidic strength. So this will increase, this will decrease. Okay. So phenols are highly acidic compound compared to alcohols. Why? Why phenols are highly acidic compounds than alcohols? Because what is present in phenol? Yes. Yes, phenoxide ion is present. Right, correct. So phenoxide ion is present. So phenoxide ion is resonance stabilized. So the correct answer is D. Okay, the D is the correct answer. So this further electrophilic substitution reactions of phenols and further part we'll see in the next class. Okay. We'll see in the next class. Thank you. Have a nice day. We'll meet in the next class.